What's the first thing you can do or tell me? Greatest common factor. You want to factor first? All right. Which one has the greatest common factor we can take out?
On the bottom, you get a 4.
So you take out 4 on the bottom. Good. What does that leave you with?
X.
All right. And when you factor the top, what do you get?
X plus 2, X minus 2.
Very good, because it is a conjugate. Good. X plus 2, X minus 2. So, what information can you give me? The domain. What is the domain? X does not equal -3. And where's that coming from? What are you doing?
Putting X plus 3 equals 0.
Very good. X plus 3 equals 0 from the denominator. What about this 4?
0.
If I write 4 equals 0, does that make any sense?
No.
No, so we don't have to worry about it. Only if there's a what? An X. Only if there's a variable in it. Good. Okay? So we're just solving that. That's why it switches to -3. Why are there no holes? Nothing cancels out. Beautiful. Very good. Okay, so then what about vertical asymptote? It's X equals -3. It is not in the domain because it is a vertical asymptote. Okay? It is not in the domain because it is a vertical asymptote. The reason things get removed from your domain is because they're either a hole or an asymptote. How about horizontal asymptotes? We look at those exponents, which in this case is x squared. Highest exponent is x squared. How many do I have in the numerator?
1.
Denominator? Uh-oh. Yeah, now let's do that, right? What if it was 0 divided by 1?
0.
Then it would be 0 and it would be okay. So there are none. There are no horizontal asymptotes. Because there's no horizontal asymptotes, we have to check for a slant, or we'll talk a little bit about like the cray-cray ones today, just because I don't want them to throw you off, okay? Can we do that at the end, though? Can we talk about intercepts first? Let's talk a little bit about intercepts. Which intercept do you want to look at first? You want to do y? What do you know about your y-intercept? 0 is always going to be your x value. Good. So that just means that I need to plug in 0 for x. So if I have 0 squared minus 4 and 4 times 0 plus 12, what am I going to end up with here? -4 on the top. 12 on the bottom. Can you make that a little prettier for me? Very nice. -1/3.
Wait, what if you, do you have to do it to the original equation, or like to your simplified?
It does not matter for your y-intercept.
Because I got 0, 0 when it was simplified. Oh wait.
There is no simplified version of this. So.
I messed up my game.
You okay?
Yeah.
You could have solved it into the factor form if you wanted to. With x-intercepts, you need to be careful and you need to use the simplified version. Although here we didn't cancel anything out, so it's already simplified. How many x-intercepts do I have in this problem? 2. And what do you know about x-intercepts?
The y is equal to 0.
Your y value is going to be 0. So how do you find these values?
You make the numerator.
Very nice. You set the numerator equal to 0, just like we did with the denominator for domain. So if I have x plus 2 equals 0, I'm going to get -2. If I have x minus 2 equals 0, I'm going to get +2. Very nice. All right, should we talk a little bit about that slant asymptote? Yeah? Let me get myself a little more space. Okay. What goes on the top, what goes on the bottom, or what goes inside, what goes outside?
With x plus 3 going with 4 x plus 3.
Ooh.
What?
Numerator's on the inside? That was clear. I like that. Okay. And numerator is x squared plus. Then why did I put a plus? What are you missing? 0. -4. Remember, when you do long division, you gotta have every spot. It's all about lining everything up very carefully. And outside of here we have 4x plus 12. Okay? So since it's division, start by dividing. What is x squared divided by 4x. 1/4 x, right? There's a 1 right here. You'll have an x that knocks out, so you end up with 1/4 x. You okay with that? What do I do now?
1/4 x plus 4.
Good. We got to take this guy and multiply it back here to see what we have left over, right? So 1/4 times a 4
1.
gives you that 1, and x times x gives you the x squared. Gorgeous. And then how about 1/4 of 12? Positive 3 with the x on it. Very good. Why am I going to grab another color?
Okay, switching columns.
Switching, because we're subtracting, right? And we're subtracting the whole thing. These guys knock out, that's what you want. What am I left with? Negative 3x. Technically, we bring down the negative 4. It's not going to matter because we don't care about remainders. And then again, you divide. So I'm starting off with negative 3x, and I'm dividing out of 4x. Negative 3/4. That, my love, is the equation of a line. So your slant asymptote is absolutely that line right there. Okay? How do you feel about that? Not how you feel, have to be happy.
Everything else.
Everything else is fine? Okay. Cool. Let's look at graphing asymptotes. Can I scoot over? We still got this thing.
We're fine.
Okay. All right. Can we graph these asymptotes? How do I graph this slant asymptote? Rise over run, but where do I have to start? Negative 3/4. So somewhere right here, right, I got a hole, because slant asymptotes aren't part of my graph, right? So we leave them open. And we have that 1/4 and a 1/4. And then down and over 4. Same deal, right? Are you comfortable with that? If you need a little extra practice of just graphing lines to get it fresh in your brain, I'm happy to pop some of that up on canvas for you, okay? That is your slant asymptote. Where else do I have an asymptote? Negative 3 on which axis? X. I'm going to cross my x-axis at negative 3. Okay? Here's why we do intercepts. Intercepts are the easiest points to find, and they're what helps us graph. Your asymptotes are what are kind of your boundaries that you're going to kind of curve around. All right? So if I know my intercept is at 0 and negative 1/3, is this going to be above or below my slant asymptote? Is negative 1/3 above or below negative 3/4? Which one's closer to 0? Anybody know? This guy. So this is going to be above it. It's really, really close. I'm going to grab a different color so you can see it. This graph is particularly, it's not a good scale for it, but the key is that it's above that. You see that? Okay? And then are you comfortable? I'm hoping, right? Plus, if you're not comfortable finding these points, we got back a lot, right? So we got a point at positive 2 and a point at negative 2. How this helps us is I know that my graph is going to be either above or below here and above or below here. And since I have points, I can give myself a nice little curve right there. Okay? We're going to get more into that next class, but I just wanted you to have a little preview of it. When you're nice and lucky, you get intercepts that are over in this section too, and then you don't have to do anything else. In this case, we would have to test a point over here and see where it landed us. Okay? And we'll get into that next class as well. Sound good? Feel pretty okay? Yeah? Awesome.